Welcome back, everyone. Today I'm going to talk to you about recursion. Recursion is a technique in programming where a function calls itself. It can be used in place of a loop. Now, it's not as efficient as a loop because there's a lot more overhead involved. Each time you call a function, you may have to declare local variables and make space for parameters and keep track of which ones go with which call. But it can be a pretty neat solution to computer programs. What you're looking at on the screen is an example from the Gaddis textbook. That's my textbook that I use for CS31, the Intro to Computer Science with Python course. In this function, of this example, we are going to call a function named message, which is right here. Now here in main, I'm calling the message function and I'm sending it a parameter of 5. This 5 gets sent to times, the parameter defined for the function. Let's look at what the function says. It says if times is greater than 0, you print the sentence, this is a recursive function, and then right here, you're calling the message function again, but you're sending it a different parameter value. In this case, you're sending it times -1. Your output is right here. You get 5 sentences in your output. Now, to explain what's happening here is when you first call this function, the first time you call it, times gets a value of 5. Obviously, that's greater than 0. So we print the sentence, and that would be the first one here. But then you also will call the message function again, and you will send it 4, which is times -1. That would be the recursive call. So the second time you call this function, here's the second sentence. You keep decreasing until when times is 1, which is greater than 0, you print the very last sentence, and then you call message and send it a 0 as a parameter. In that case, 0 is not greater than 0, and that function ends, and the whole program eventually ends. Probably a better way to explain it is this. So here's what's happening with the message function. The first time you call it, the value of times is 5, and you get a sentence printed out. But then you're calling it 5 more times. The next time you call it, the value of times becomes 4, you print a sentence. Then times becomes 3, and you print a sentence. Times becomes 2, and you print a sentence. Then times becomes 1, and you print a sentence. Now, when times becomes 0, you don't print a sentence, and then all the other calls end. You eventually had to get to a spot where the recursion would end. Very similar to how you have to set up a loop so that the loop will eventually end and not become infinite. We call that a base case. So a base case is a way that the problem is solved, but does not involve recursion, or where the recursion ends. For all the others, you get a recursive case, where you might do something, but eventually you will call the function again. So when times is 0, when the number is 0 would be our base case for this particular problem. When times is greater than 0 would be our recursive case. If it's greater than 0, then keep calling the function recursively until you eventually get to the base case. If you don't get to the base case, your recursion goes on infinitely, just like an infinite loop would do. And we don't want that. Let me show you some examples in Python. Okay, here's the first one. Okay. In this one, we are using a recursive function to print numbers 1 through num, whatever num is. Okay, so here I'm asking the user to enter a number, and I'm calling my display function, and I'm sending num as a parameter. Now I have to think about what's my base case. Well, if I'm printing numbers 1 through something, if num is a 1, then all I'm going to print is the 1. So here is the base case. When n is 1, call the display function with 1 as a parameter and print the 1. My recursive case would be, okay, n's greater than 1. So in that case, I want to just call display with n minus 1. Now, I've tried to explain in the comments what's going on with this particular function. So what's going to happen is, I'm just going to read these comments to you. Each call will not finish. That means it won't print. It won't call this print until display is called with 1 as a parameter and it prints 1. After the 1 is printed, each call will print the number that goes with it. So suppose I give display a 5. 5 is greater than 1, so call display with a 4. 4 is greater than 1, call display with a 3. 3 is greater than 1, call display with 2. Then you call display with 1. Okay? Well, 1's not greater than 1, so you're going to print the 1. And since you already did the if, that means you print the 1. Then you're going to go back and print the 2, go back and print the 3, go back and print the 4, and go back and print the 5. So when I run this, 5, I get 1, 2, 3, 4, 5. Try it again. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But what's really happening is we don't start printing at all until the parameter becomes a 1. In this case, the parameter when I first called the display function was 10. So we actually are counting down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 by recursively calling the function and making the parameter smaller each time. 1 eventually gets printed, and then the 2 is printed, then the 3, then the 4, then the 5, all the way to the 10. And that's one way that recursion works. Here's another example. This is probably the most common example of recursion you'll see in any computer textbook. It involves doing a factorial. So here's what we're going to do. Prompt the user to input a non-negative number, and then use recursion to find the factorial of that number. You cannot take the factorial of a negative number. Now, the factorial of 0 is 1, so that's going to be our base case. So if num, the number entered by the user, is a 0, then 0 factorial is a 1, so just return 1. 0. Recursive case will be if num is greater than 0. Well, let's do a little mathematical gymnastics and see how we can figure this out. Well, whatever num is, if it's bigger than 0, its factorial is equal to this. You take 1 times 2, all the way up to times num. You multiply all the numbers between 1 and num together, and that gives you the factorial. Notice, in my definition, I included like num minus 1. For example, if num is 4, it's 1 times 2 times 3 times 4. Well, we can write this in reverse order. Start with num, and then go to num minus 1, and then go all the way to 1. This right here, from num minus 1 down to 1, that can be rewritten as num minus 1 factorial. So num factorial, whatever num is, can be expressed as num times the factorial of num minus 1. So in our function, for the recursive case, we will return num times factorial of num minus 1. That is how we will recursively call the function. So here I'm inputting num in main, and here's where I'm going to call the function. Here is my base case. If n is 0, return a 1. And my recursive case will be in the else in this case. Else, return n, that's the name of my parameter, times factorial with n minus 1 as the parameter. If I run this, 4 factorial is 24. Try a bigger number. 8. 8 factorial is 40,320. How about 0? 0 factorial is 1. How this works. One more example. Here we have a recursive power method. Have the user enter two numbers. One is for the number to be raised, that'd be the base. I know we're using that word again. And the other is for the exponent. Let's make sure the exponent is non-negative. Use a recursive function to raise the number, the base, to a power. So here I'm inputting both. Let's look at the base case. The base case would be if e, the exponent, is 0. In that case, you're going to return 1 because anything raised to the 0 power is a 1. Recursive case would be if e is greater than 0. So return b, which is the base, times call the function. You're calling the function recursively here. You send it the same base, but look what you do to the exponent. You're decreasing the exponent by 1. Raising a number to a power, like say 2 raised to the 5, is the same thing as saying multiply 2 by itself 5 times. That's what we're doing. So down here in the function, here is my rec power function. My two parameters are there. Here's my base case. If e, the exponent, is a 0, return a 1. That's what you're going to get. And otherwise, if it's bigger than 0, return this. You return b, the base, times the recursive call. You're calling the rec power function. You're still sending it b, but now for the exponent, you send e minus 1. When you do that, say 2. Exponent is 5. Hey, 2 to the 5th is 32. How about 5 raised to the 5? 3,125. How about 2 raised to the 10? Yeah. 15,478 raised to the 0. It's 1. There you have several examples of how to do recursion. If you have any questions, please send me an email at kmuldrow@lbcc.edu.